So you're interested in braking the speed of hydraulic motors. Okay, great. Well, let's talk about brake valves today. The brake valve is a pressure control valve that would be mounted in the circuit on the A or B lines going to the motor. But first, let's take a look at the brake valve and see the different parts of it. So it's a normally closed valve in that the spring that's adjustable would push the spool down to the closed position. The inlet port would be over here, and of course you follow this green arrow that points to the outlet port. But in this position there would not be any flow through the valve because the spring would be holding the valve on its normally closed position. Now it has pilot pressure to open the valve, and the pilot pressure comes from two different places. We have external pilot pressure, as you see in red here, and that's coming from an external port on the valve. We also have internal pilot pressure, as you see in blue here, that's coming from the inlet side of the valve itself, so it's internal to the valve. The external pilot pressure exerts its force on a large piston area. The internal pilot pressure exerts its force on a small piston area. There's about an 8-to-1 ratio between the two areas. So if we adjust the valve so that it takes 800 psi to open the spool under the small piston, then it will only take 100 psi to open the valve underneath the large piston. So there's the 8-to-1 ratio. Most of these valves also have a check valve built in for reverse flow. Okay, so that's what the valve looks like. Next, we're going to put the valve in a circuit and see how it operates. Okay, so here we have the valve mounted in a circuit. Here's a hydraulic motor over here, and in this case this motor is running clockwise because we had the directional control valve, as you see here, shifted to allow the pump flow to go through the A line to the motor, turn the motor clockwise, come out of the other side of the motor and go back to tank. Now in order for that fluid to go back to tank on the B line, the brake valve needs to be open, right? Okay. Well, it's set for 800 psi. Okay. That means it would take 800 psi under the small piston to open the valve, and it only takes 100 psi under the big piston to open the valve. Notice that the external pilot pressure that feeds into the big piston is connected to the A line. So as soon as we get 100 psi, and we're going to have 100 psi plus in the A line because it's going to take a lot more than 100 psi to run this motor, but as soon as we get to 100 psi, that's the pilot pressure that will open the brake valve. So when we're running, when we intentionally want to run that motor, we want the brake valve open. We don't want to be putting on the brakes when we want it to be running, right? So that's what that external pilot line does for us. It opens this valve up wide open so the motor can run. Okay, so there we have the motor in the run mode. Okay, now let's say that we now want to stop the motor. So to stop a motor, notice that we take the directional control valve, go back to the neutral position. And a real common neutral position, center position for a hydraulic motor circuit is an open center valve. All four ports open to each other. So once we allow this directional control valve to center up, then we lose our pressure in both lines. So we lose our pressure in the A line and in the B line because all of those, or both of those lines are connected back to tank. So if we lose our pressure in the A line, we no longer have pilot pressure under the large piston holding the brake valve open, therefore the spring will close the brake valve. As soon as that brake valve closes though, we're going to start building up back pressure on the motor. That back pressure is what slows the motor to a stop. But we don't want this valve to close quickly and just stop that motor quickly because that would damage something. That would be too much braking. So as soon as this valve closes, then the internal pilot pressure takes over, and remember it's going to take 800 psi now in the internal line to open this valve. And so the 800 psi that it takes to open the valve to allow the motor to coast, or to allow the motor to continue to turn, is the 800 psi back pressure that brakes the motor to a stop. Now if you want the motor to stop more quickly than that, you can adjust the valve for greater than 800 psi. If it's stopping too quickly, you can adjust the valve for less than 800 psi. So here we have the hydraulic motor in the braking mode. Okay, now I mentioned the check valve that's built in. The check valve that's built into the the check valve that's built into the brake valve is there so that we can reverse that motor, go in the opposite direction. So here we have shifted the directional control valve. So now the oil coming from the pump goes out the B line into the brake valve, down through and opens the check valve through this passageway, and then is available to that motor to run the motor counterclockwise. And of course the oil coming out of the other side of the motor is directed back to tank. So here we have the motor in the reversing mode. Now I need to point out, we don't have braking when we're going counterclockwise with this motor. We only have braking when we're going clockwise. If you want braking in both directions, then what you need will be two brake valves. You would put another brake valve in the A line, just like you have in the B line. Then you could have reversing, or you could have braking in both directions. Okay. But there's another way to do this. If you want braking in both directions, then a lot of times what we use is the cross-port relief valve. So here is a cross-port relief valve plumbed into the circuit instead of a brake valve, but it's going to do the same thing. It just functions a little bit differently. So here we have the directional control valve shifted so that the motor is running clockwise. So the oil is coming from the A port of the directional valve right straight through this passageway in the cross-port relief valve body to run the motor clockwise. The oil coming out of the other side of the motor goes back through another passageway in the cross-port relief valve, and that oil goes back into the B port and goes back to tank eventually. So a cross-port relief valve, as you see here, it has two ports through the body. It also has two relief cartridges. One cartridge will relieve from one side to the other. The other cartridge will relieve from one side to the other. So with two relief cartridges built in here, we have individual adjustment on when those relief valves will open, and we're going to use those for braking the hydraulic motor. Okay. Right now the motor is in the run mode, so we're not braking. However, if we go to the center position of the directional control valve, now in this case we're going to use a directional control valve that has A and B ports blocked. This is a tandem center valve, or it could be a closed center valve. Either way, we're going to have A and B blocked. If we just block A and B while we're running a motor without the cross-port reliefs, that motor is going to stop instantly, and that's not good because it would blow a hose, or maybe it would damage the workpiece that the motor's turning, or it could ring off a shaft or break a coupling or something. So we want this motor to coast to a stop. So when we go to the center position of the valve, we blocked A and B ports. So B port is blocked. That means the oil coming out of the motor now no longer can go back to tank through the directional valve. So what's going to happen is pressure is going to build up. That pressure that builds up is going to open this particular relief valve cartridge, and it's going to dump the oil over to the other side and go back through the motor. So now we have oil just circulating through this relief valve cartridge back through the motor, round and round, until the motor comes to a stop. If you want the motor to stop more quickly, you adjust more pressure on the relief cartridge here, and the motor will stop more quickly. If you want it to take a longer time to stop, then you will adjust the relief cartridge to a lesser setting. Now if we're running counterclockwise, we have the directional valve shifted in the other position so that the fluid goes out the B port, runs the motor counterclockwise. The oil coming out of the other side of the motor goes back through the cross-port relief and then goes back to tank. Okay, so that's the motor running in the opposite direction. Now if we go to the stopping mode, that means we once again go to the center position of the directional control valve, which is going to stop the motor, but it's not going to stop it abruptly because the motor is still turning and the oil is coming out of one side of the motor, can't go back to tank, so it pressure builds up, it opens the relief that's going to relieve from this passageway down to this passageway here. So this relief cartridge now is the valve that's putting back pressure on the motor to stop the motor when it's going in the counterclockwise direction. Now, I've also added something here that's really important when you're running motors with cross-port relief valves. I've added what we call anti-cavitation check valves here. Because what happens to a motor, when a motor is running, it's running the load, it's turning the load, but when you go to the braking action, then the load is actually running the motor. So the load becomes like the prime mover. The motor then becomes a pump in essence, and it's actually pumping oil around and around the circuit here, out of the motor, through the cross-port relief, back into the motor, round and round. Except some of that oil is going to be leaked out of that circuit that's created there. Sometimes it's through an external drain, as you see over here. Sometimes it's through internal passageways in all the components. So we don't want that motor to be starved from oil. It's just like running a pump without enough oil. It's going to cavitate. So to keep the motor from cavitating when it's in the braking mode, we add these check valves here that are called anti-cavitation checks. Now in this case, what's going to happen if we're braking in the counterclockwise mode, as you see we're going around and around like this, then if that motor needs some replenishment oil, what's going to happen, there will be a vacuum created on the inlet side to the motor, and that vacuum will open the anti-cavitation check on this side and siphon in a little oil to keep the circuit full of oil. The other anti-cavitation check on the other side is for when you're braking in the clockwise mode. Okay, so those are really important valves to have there. Sometimes they're built in to the cross-port relief, but if they're not, they can always be added as external valves, as you see here. Okay, that's it for brake valves for braking the speed of hydraulic motors. Come back next time and we'll look at another pressure control valve. Thank you.